Hi, and welcome to a tutorial on how to make a laser in Scratch. You might have seen my reflections project on YouTube. Here it is. Here's the reflections project. So it's basically just a laser pointer that you can control with the mouse. And today I want to show you how to make a tutorial on it because a lot of people have requested a tutorial on it. Okay, so without further ado, let's get started. So I have a new project right here. I'm just gonna rename it to something like realistic laser bounce in Scratch tutorial. Okay, so first thing we want to do is we want to make a level sprite. So let's delete the Scratch guide and we're gonna paint a new sprite, and this is gonna be called level. And all we're gonna do is make a simple level. So make sure that this level is surrounded on all four sides with a border. I'm just gonna make mine purple, but you can color it any color you want. So I'm just gonna make a simple border, and I'm just gonna add a block, and let's just add a 45 degrees right there, and then I'm just gonna add maybe like that. And then all I'm gonna do is make something maybe like that and twist it a little bit. Nope. And I'm just gonna twist it like that, maybe. Okay, cool. There's our level. So on the stage, as you can see, it is not centered, and we want it to start centered. So let's go to the code tab. Make sure events when green flag clicked, motion, go to X, 0, Y, 0. Okay, cool. So now we have, let's just click the green flag. And perfect. So we see that the level sprite has gone directly to the center of the screen. Cool. Okay. Now let's make another sprite. Just paint a new sprite, and we're gonna call it laser. Oh, that's not how you spell laser. There we go. Okay, and all we're gonna do here is we're just gonna zoom in a really big amount, and we're just gonna draw just pretty much a dot onto the screen, and then we can just shrink that dot to not like that. Let's just shrink the dot. Oh. There we go. Shrink the dot until it's very tiny, like that. Actually, that might be too tiny. Okay. So I would recommend something like 8x8. So that's just gonna be like that. So there's an 8x8 circle. You can make it smaller, but don't make it too small. Okay? That's just my one warning. Don't make it too small, please. Okay. So now we have a reflections laser sprite. I'm just gonna color it a nice bluish color, like that. Paint it. Okay, so now we can differentiate it. Okay, cool. Okay, so first thing we want to do is we want the laser to start from the center. Now you can totally do something else. That's fine. I'm just gonna make it start from the center. Okay, so go to events when green flag clicked, and let's just make sure it goes to 0, 0. And then let's create a new block to do all the laser calculations and stuff. So make a new block, call it laser calc for calculation, run without screen refresh, and then click the OK button. So define laser calc. This will just calculate all what the laser will do. So let's drag a forever loop, and then let's drag a laser calc. And before the laser calc, let's create a new block called laser draw. Draw, and run without screen refresh, click OK. And this laser draw we can just put underneath the laser calc. Great. Okay, so first thing we want to do is laser draw. So when we're drawing, it's pretty simple. So we just want to draw a dot to the screen, which isn't that hard. So let's go to motion. Let's add an extension, pen. And then at the very beginning, before laser calc, inside the forever loop, let's erase all. Let's just zoom in a little bit. Erase all like that. And then inside laser draw, what we're gonna do is we're gonna set our pen color to a laser blue, like that. And then pen down, pen up, and that should just draw a dot to the screen. And if I'm correct, if we just hide it, if we zoom in, yep, there's a tiny little dot there that the laser drew. Cool. We want this dot to be a bit bigger, so we're just gonna set pen size to, let's say, 10. Okay, let's see what that looks like. Yeah. So now there's a laser sprite, and we can drag it around the screen. Okay, great. So now we have a laser draw, and this will just draw a dot to the screen wherever the laser goes. So let's say inside laser calc, let's just add a move 10 steps just to show my point. So if we do that, click the green flag, as you can see. Okay, so all we have to do is add a repeat, and just repeat laser calc like 100 times. Let's just say that. And okay, so let's make sure we're going to 0, 0 at the very top of our laser calc block. So go to x0, y0. Great. So now, as you can see, it will just draw a line from there, but make sure it's not 10. Let's just make it to like 1, so it's an actual line and not like just a bunch of circles everywhere. Okay, now let's make this laser point toward our mouse pointer. So all we're gonna do is at the very beginning of the laser calc, we're just gonna point towards mouse pointer, and there we go. We have a laser working. Great. Okay, so now we just need this laser to bounce off objects, but my laser isn't long enough to bounce off of any objects. So all we have to do is increase this repeat number. I'm just gonna make it 300. Okay, great. So now we have a laser that repeats 300 times and keeps going to the edge of the screen. Great. But we don't want the laser to pass through walls, do we? So we have to fix that. The easiest way, let's just see if this works. So inside laser calc, all we're gonna do is grab an if inside the repeat loop underneath the move 1 steps, if touching level, then inside control, stop this script. So let's just test that, and that should just stop the laser at the wall, and yes, it does. Cool. So now all we have to do is make sure that the laser bounces properly. So that's actually quite difficult. So inside the if touching level, before we touch the level, if we're touching the level, that means we're inside the level, not just barely touching it. So that means all we have to do is move back 1 step. So just go to motion, drag a move -1 steps inside the if touching level. Great. Now you really shouldn't see a difference here. It just makes sure that the laser is not inside the wall, right? Okay, now let's make sure that we can bounce the laser off the wall. Now, this is actually quite a difficult challenge, okay? Because we need to find the exact angle of this reflection. Alright, so we're going to need to set up a few things before we can actually make the laser. The first thing is, instead of using a move 1 step, we have to actually use an X and a Y, which is kind of annoying, I know, but it's really hard to do without calculating the speed X and the speed Y. So let's do that right now. So we're inside variables, we can delete the my variable, and let's create 2 new variables, SX for speed X, and SY for speed Y. Both of those can be for all sprites, which is fine. So at the very beginning, we're just going to reset those. So set XSX to 0, set SY to 0. Okay, and then inside laser calc, instead of moving 1 step, all we're going to do is we can get rid of those. Get rid of the move 1 step, get rid of the move -1 step, and then we're just going to set SX to, we're going to grab a sign, so grab an abs of, and then change that to sin, or sign. I don't know why people call it sin, but I guess it looks like sin, but it's actually sign. Yeah. Set SX to sign of, go to motion, direction. Okay, and then we can duplicate that, and then set SY to cosine, or cause of direction. Okay, so if we just hit the green flag now, as you can see, the SX and SY are being calculated. And that seems about right, so if I point my mouse straight up, as you can see, SY is 1, pretty much, and SX is 0. If we point to the right, SX is 1, SY is 0, right? And anywhere in between. So that seems about right. Now let's just make sure we're moving in those directions. So all we have to do is change X by SX, and then change, oh no, can't do that. Go to motion, grab us, change Y by SY. Okay, great. So that should not change anything, so yeah, so perfect, great. So, good job team, we did it. Okay, so now we have a laser, and it's working exactly how we thought it would just stop at the edges. Cool. Now all we have to do is detect the collision. Okay, so before we do that, we need to set it up a bit more, so let's go ahead and go to the costumes. We have to create a new costume for detecting the edge. So, rename this first costume to Dot, and then duplicate the Dot costume. Make sure we're zoomed to the normal, so all the way out, so make sure just click this plus button, so we're all the way out. Select the dot, and then we're going to click the right arrow key 6 times. 1, 2, 3, 4, 5, 6. Great. Okay, And now we can zoom in, and as you can see, it's moved it by about that much. So, yeah, okay, cool. And we can rename this to sensor. Okay, because this is going to be sensing the collisions, right? Okay, so let's create a new block for this, okay? So let's create a new block, and this is going to be calculating our bouncing, okay? So all we're going to do is let's create a new block called bounce. And we need to do two inputs, which is SX and SY. Or actually, instead of this, we're going to do NX and NY, and you'll see why in a moment. NX and NY. Run without screen refresh, click OK. Great, so now we have a bounce block, and all we're going to do is we're going to go ahead and not use that right now, because we don't need it right now. Okay, so let's create a new block that calculates the collision, okay? So we're going to create a new block, calling it collision bounce, like that, and run without screen refresh. Click OK. Now we need to create a new variable. Let's create a new variable, and we're going to call this the original angle. So orig angle works fine, and for all sprites is fine. Click OK. Great. So now at the very beginning, we're just going to set orig angle to, so this is going to be setting, just keeping the original angle kind of not destroyed, I guess, so that we can preserve the original angle, let's say. Okay, and then here, we're going to make sure to switch costume to our sensor, and then we're going to calculate what's known as a surface normal. Now, a surface normal is basically a vector, so an arrow, that points away perpendicular to the surface, and from that we can calculate the direction of bounce. So this is actually kind of complicated, but try and keep up with me. Okay, so calculating a normal isn't too difficult, so let's try and do it right now. So we're gonna create a new variable, dir, for direction for all sprites. Okay, and dir we're just gonna set that to 0 at the very top of the collision bounce. And then we're just going to point in direction dir. Okay, now let's make sure that if we are touching the level, we're going to move out of the level first. So we're going to first check if else, are we touching the level? So if we're touching the level, we're going to have to move out of the level. So if touching level, we're going to rotate out of the level. So we're going to repeat until not touching level. Not touching level, not add a comment, touching level, and then what we're going to do is we're going to create a new block, calling it rotate, and then this is just going to rotate by a certain number of degrees. So we're just going to create a new number, a new input, degrees. Great. Run without screen refresh, click OK. Okay, rotate in degrees. So what this is going to do is rotate in degrees. Okay. So all we're going to do is, inside here, inside variables, we're going to change dir by degrees, and then point in direction dir. Not degrees, sorry. dir. Like that. Okay. So, now we need to rotate. So, we need to just grab this rotate block, and all we're going to do is rotate by positive 15. Okay? And then all we're going to do is, after this repeat ends, that means we're not touching the level anymore, so we're going to create a new variable called wall1. This is going to be marking the angle of the first wall. So wall1 for all sprites, and we're just going to set wall1 to dir. So this is going to mark the direction where we start marking our wall, right? That might not make sense, but it will in a second, trust me, okay? So if we just try that right now. Oh, right. Okay, we need to actually put the, so first of all, we need to make sure that inside here we have to use the collision bounce. Let's use that let's do it right before so at the very beginning of the repeat loop, and then after that, let's make sure to switch costume to dot. So right before and right after, let's make sure to switch costume to dot. Okay? And that might lag your project, or not. Maybe? Maybe not? Okay, I think we broke it. Hang on. Let's implement the rest of the scripts first, and then if it keeps happening, we'll fix it later. Okay? That's how coding works, by the way. You just keep going unless it's a real problem, and then you work on it later. Okay, so all we're going to do is we're going to duplicate this and stick this into the else. Okay? And instead of not touching level, we're going to do touching level. And then we're going to rotate by -15 this time. And then set wall1 to dir, set dir to 0, and then point in direction dir. Okay, so great. And then after that, we're just going to repeat until touching level again, and then rotate +15, so this is going to mark the second wall, right? And then all we're going to do is, after that, we're going to just set dir to, grab a division, we're going to just take the average of those two directions, so we're just going to add wall1 to dir, and then divide that by 2. So now, all we have to do is bounce it, but let's just test if that works, and it broke, okay. And it's lagging the project, okay. Why is the direction like that? Oh, okay. So, we have to make sure that this is contained if we're actually touching the level, right? So, it's going to have to be inside the stop the script, so we can get rid of this, take this if, and surround these 3 scripts inside that, like that. And let's just take out the first switch dot, and let's just stick that at the very top there. Okay, let's just see if that works. Yeah, okay, but now, as you can see, it's kind of like wrapping around, which is kind of cool, if that's what you're going for, but, like, that's not exactly what we wanted. That's cool, though. It's really cool, isn't it? Yeah. Okay. Hang on. I'm trying to figure out what's going on here. Huh. Oh, okay, so, all we have to do is, you know what, it's okay. That's normal. Okay, it's fine. Okay, now let's set up our bounce script, okay? So, let's set up our, where's our bounce script? There it is, okay. So, our bounce script, we're just gonna make sure it bounces, so, which kind of makes sense. So, let's drag a bounce script in there, like that, right after the switch costume to dot. And all we're gonna do is we're just gonna go ahead and use sign of, instead of direction, we're gonna use the variable dir. And then same thing, just instead of that, cosine of dir. Pretty simple stuff. Okay, now inside this bounce, we're going to calculate our dot product, which is a vector multiplication system kind of thing that's really annoying to explain, okay? So just take my word for this. This is going to be basically the amount that we have to rotate by, kind of. I guess yeah. So if it's fine. Just trust me on this. It'll work. Okay. So let's create a new variable dot product for all sprites is fine, and then product. Okay, I'm gonna rename that. I can't have spelling mistakes. Product. There we go. Okay. So we're just gonna set dot product to, and the way to calculate dot product is grab addition. And we're going to grab 2 multiplications, like that, and then put sx and sy there, and then put nx and ny in there. Okay, great. And then, actually, if we just try that, there we go, dot product is being set. Nice. Okay, yeah, okay, cool. So, all we have to do is now change our speedx by, and actually, let's just take out the set sx and sy inside here. We're going to take that out, and we're going to put that above the repeat. Okay, we're going to change sx by, we're going to grab a multiplication, -2 multiplied by sx multiplied by dot product, there we go. Change and duplicate that, change sy by 2 times ny multiplied by dot product. Okay. Now, if all the calculations are correct, that should work, but there's a high chance that the calculations are not correct, and then I'll have to debug. So let's just try it. And it's lagging a lot. Okay. So, as you can see, it broke. Okay. I knew it. Okay, I'll be back and try and fix it. Okay. Alright, I found the solution. The simplest solution is a grab -15 and inside collision bounce, inside this first if, set wall1 to dir minus 15. And that should fix it. So, yep, that fixed it. And I have no idea why. Oh, it didn't fix it. Okay, back to debugging. Okay, so here's my solution. All we have to do is grab our sensor. We're gonna press a left arrow like 6 more times. 1, 2, 3, 4, 5, 6. There we go. And that should pretty much fix it. Yeah, okay. Yep, there is our fix. It worked. Yay, good job. Good job, team. We made a laser. Okay. So, as you can see, it's pretty much reflecting nicely. Sometimes it's very weird, but that can't be helped. It's, of course, I could design it. There's a much better way to do this, but this is the solution that I've come up with, and it's pretty accurate. So I think if you're just making a simple laser shooting thing, I think this is pretty good. So like, for example, if I shoot against this 45-degree wall, it sometimes jitters, but most of the time it's accurate. So I think this has been a success. So for example, if you want to like make the laser longer, all we have to do is inside the laser calc, all we have to do is set this like 1,000 or something. Let's just do that, and let's just see. Yep, there's a really, really long laser, and it jitters around a lot because, yeah. For example, there is a nice path. Yeah. Great. So now we have a very nice little laser script to work with. Great. So I can see this used for like games and like projects that use light and, you know, a lot of just cool stuff. So thank you for watching. I hope you enjoyed this video. If you did, please consider subscribing and liking and sharing this video with others. And make sure to join the Discord server down in the description below. Okay, thank you for watching. See you at howtodotothelething.com, and see you next time.